Up now we have Michael Schuldenfrei. He brings over 35 years experience in software development and is focused on long-term innovation and software strategy at National Instruments. Michael joined NI from Optimal Plus, where he served in several leadership roles, including Chief Software Architect and CTO, designing, architecting, and prototyping many of its flagship products, as well as providing support for sales and marketing.
Okay, thanks very much for the introduction, Neil, and thanks to Ira for arranging this fascinating event. It's great to have the opportunity to be here to discuss some of the challenges and opportunities associated with chiplet-based modules. So in this presentation, I'm going to share a novel approach and solution that NI is currently developing to solve many of the unique and difficult challenges that are common across all devices that use advanced packaging techniques, including chiplets. But before I dive into chiplets, I'll introduce NI and explain why we're presenting in this event. As many of you probably know, NI, or National Instruments, has been a leader in test and measurement across many industries, including semiconductors, for the last 50 years or so. The company is probably best known for LabVIEW, which revolutionized the way electronics testing is done, leveraging software to drive innovation and accelerate product development. And NI is also known for its high-performance lab equipment and production test and measurement systems. The company's vision is all about giving engineers the tools, services, and systems they need to engineer ambitiously. Now, in recent years, NI has invested significantly in software for analytics, with the vision of transforming test from a necessary evil to a key enabler of product performance. And last year, as many of you probably know, NI acquired Optimal Plus, the company I worked for the last 15 years. And we're currently working hard to build on our extensive market reach in semiconductor test and beyond. So we're currently processing test data from over 100 billion devices a year for many of the largest companies in the industry, and we're improving yield, efficiency, and quality. But I'm not going to turn this into a pitch for NI's existing analytics solutions. Instead, I want to focus on the next revolution in analytics and propose a methodology to take analytics to the next level. So let's focus on chiplets. Some of the speakers over the course of this event have emphasized the unique quality challenges that are typical of advanced assembly processes, such as those using chiplets. Fundamentally, these can be boiled down to several issues. Firstly, there's high sensitivity to process variability in the chiplets themselves in advanced process nodes like 5 or 3 nanometer. Secondly, the interdependency between the various chiplets on the substrate creates a compound yield problem, particularly when combining heterogeneous devices in the same package. So one faulty or poorly performing chiplet can disqualify the entire package. A module of 10 chiplets, each of them contributing a loss of 1% yield, is going to leave you with 10% yield loss at the module level. And that, of course, is completely unacceptable. Thirdly, the package itself may perform differently under different environmental or use conditions, which is difficult to test and may require techniques for in-field testing and tuning. And of course, finally, since the device typically consists of chiplets from multiple suppliers, and subtle interactions between the chiplets can lead to significant yield and quality issues, end-to-end collaboration across the value chain becomes critical. Without that, it's difficult to ascertain whether the issues are coming from the chiplets or the packaging. And all of this is exacerbated by the current supply chain constraints, which seem likely to continue for the foreseeable future. It has become critical to squeeze every last percentage point of yield out of the manufacturing process to meet demand. So there are many robust and powerful data-driven techniques to improve the quality of chiplets that are already well established in the industry. Things like outlier detection and escape prevention. They're ubiquitous and they're used by just about everybody. So companies routinely use analytics platforms like ours to connect all of the silos under their control, including across outsourced manufacturing and test. But we believe that by going one step further and connecting silos across the value chain, it'll become possible to generate significant value for all of the suppliers and customers by holistically increasing yield and preventing quality escapes. In fact, there are plenty of proof points that sharing manufacturing and test data across the value chain has the potential to solve some of the most pressing industry challenges, from the need to develop and launch new products fast, through the need for consistent performance, and all the way to warranty, recalls, and liability. But the big question is whether any type of data sharing, particularly for sensitive data like test data, is something the industry can stomach. So before we talk about how shared data can help and how it can be achieved, let's see what the industry has to say about this. The Boston Consulting Group, BCG, recently published a report for the World Economic Forum talking about the value that can be derived from cross-industry data sets. This looks at a much broader ecosystem than pure semiconductor manufacturing, but the full report contains a wealth of information and great examples about some of the potential use cases and early adoption, many of them in the broader electronics ecosystem. The bottom line is that the analysts believe there is tremendous untapped value waiting to be realized, and this is a great opportunity for early adopters. But of course, it's not just the analysts. AWS and Azure and other cloud vendors are working on solutions that leverage data across the value chain and across competencies to drive value. Audi and BMW are examples of automakers who are publicly pressing for more collaboration across the value chain and proposing a more centralized spoken wheel approach to supply chains instead of the classic supply chain pyramid. But perhaps the most concerted effort around data sharing today is happening in Europe. Several years ago, the European Union launched a project called GAIAX. In their words, GAIAX was initiated to enable a secure, open, and sovereign use of data. GAIAX is an extremely broad initiative. It's not focused on any particular industry or any particular type of data. However, several initiatives have spawned out of GAIAX and are targeting more specific use cases. Perhaps the most interesting of those is CatenaX, which was launched last year. CatenaX is focused on the automotive industry. It's led primarily by German industry and already boasts active participation by all of the major German automakers and many of their suppliers. So although their initial focus is on the European market, the intention is to quickly expand the initiative globally. So the bottom line is there is a broad consensus that data sharing and the ability for organizations to collaborate on data is the future of data analytics, and there's tremendous value still to be realized. But let's go back to chiplets and specifically the benefits of shared test data. So once again, thanks to solutions like our Optimal Plus offering, semiconductor companies are already realizing the benefits of breaking down data silos and analyzing and correlating data from across multiple test insertions, from wafer acceptance sets, wafer sort, final test, and burn-in, and that's old news. And since packages will often contain chiplets from multiple suppliers, the next generation of analytics needs to go much further and break down the silos between organizations and across the value chain. And we believe the best way to achieve this is through a shared analytics hub. So what is a shared analytics hub? Well, the idea is to enable analytics on data sets that span the value chain, but without actually providing the data itself to the other party. In cases where we've been able to build data sets that span chip test and package test of multi-chip modules, or even from chips to boards as we've done in the automotive industry, it is possible to see how some package level issues are directly related to specific wafer level issues from the fabrication of the chiplets. For example, the two wafer maps here show reconstructed data based on cumulative binning data from packages. And in one of them, you can see a clear pattern of package results being reflected back on that wafer and demonstrating that the wafer is actually probably the cause of the problems. Now, to achieve this level of mapping, we needed data from a pick and place machine to solve the lack of ESIDs. And we used that to construct the genealogy of each package. So we know which specific chiplets or die went into each package. When we reconstruct the final test binning data from the wafer data, we see a clear pattern. And it's possible to drill down further to identify specific parametric tests in wafer tests that correlate to the package level failures. Now, a big benefit of analyzing combined data sets is the ability to increase the quality of both the chiplets and the final package device, while at the same time actually increasing the yield of both the chiplet manufacturer and the package builder. So in this example, without the ability to analyze a combined data set, the chiplet vendor is forced to apply a stringent outlier detection process with 6 sigma limits across hundreds of key parameters. But with a combined data set, and over time by finding the wafer level parametric tests that truly correlate to downstream performance or quality issues for a specific product, it's possible to identify a smaller set of parameters that truly impact the final product and limit outlier detection to just these parameters, increasing the supplier's yield for this particular application. And now that we know which parameters can be used as predictors of quality for the package, we can tighten the outlier detection parameters to 4 sigma, improving quality and final package yield while simultaneously increasing chiplet yield. So think about what this means in terms of chip shortages. We can increase yield while improving quality and reliability at the same time. So we've seen that there are compelling reasons to share data. So let's deal with the elephant in the room. Nobody wants to share data with anyone, and for very good reasons. Companies tend to think I'm exposing my most sensitive IP to my customers and suppliers. Anything I share can and will be used against me. I have serious concerns about how my data is stored and managed by my business partners. What about legal ramifications such as privacy and sovereignty? And even if I agree to share my data, what about the technical issues managing the connections to myriad partners, managing their data and its security, integration, traceability, and so on? It's an IT nightmare. And finally, even if I get data from my partners, do I understand it well enough to know what to do with it? All of these are legitimate concerns and likely the reason why data sharing is still very rare in our industry. So the solution we're proposing to the industry is to create a hub through which any partner in the value chain can expose data sets for analytics. There are some really important aspects to this approach that I want to emphasize. So firstly, although data is exposed to the hub, it is never exposed or sent to any of the other partners. Instead, the hub is used to correlate data sets and provide insights to relevant partners about parameters in one data set that can be used to predict outcomes in another data set. For this to work, there does need to be some level of device traceability, at least at the batch level, but preferably at the individual unit or die level, that can be used to tie the data sets together. And once again, this could either be inherent in the device through a chip ID or through some kind of 2D marking, or it could come through the pick and place machines that are actually taking die out of an original wafer and placing them in a package. Secondly, the hub follows the principles recommended by organizations like GAIAX that I mentioned before, and uses the concept of federated services to make data available to the hub. In other words, data doesn't need to be stored in the hub. Instead, the hub contacts the data supplier for a given data set and requests the data on behalf of another partner. It then runs the analytics on the aggregated data set and discards the data itself. The data providers remain the owners and managers of their own data and don't relinquish control to any other party. And finally, even the data that is exposed to the hub doesn't need to be in its original format. The services at each data supplier can obfuscate the data sets in ways that hide meaning while still enabling analytics. So these fundamental design assumptions mean that all of the data suppliers need to have systems to provide the services and enable users to configure, control, and monitor data sharing securely and robustly. So if we think through the concerns we discussed previously, we've dispelled the IP and commercial concerns by leveraging the hub to hide the data from the other parties, using federated services to control data ownership and obfuscating data at source. Technical concerns are mitigated by centralizing and simplifying the many-to-many connections that every participant needs to manage through a single connection to the hub. And finally, the hub itself, through the IP built into its analytics capabilities, can provide much of the needed expertise. So you might ask yourself, how practical or immediate is this? On the semiconductor manufacturing side, most of the global test houses and major chip manufacturers already have the NI Optimal Plus infrastructure that can provide high-quality data sets to such a hub. For customers interested in participating, we plan to provide the service infrastructure to connect to the hub, manage data access permissions, obfuscate data, and visualize insights. And since NI is already working with tens of thousands of manufacturers further down the value chain, we believe we can rapidly ramp the solution across the industry. So in summary, chiplet technology is yet one more application that is crying out for shared data. We believe that data sharing is inevitable, and there's an opportunity for companies to be early movers, offer shared data analytics services to value chain partners to help solve pressing issues such as the current supply chain constraints. And doing this without a hub is difficult. And even with a hub, it still requires companies to work on building out the business relationships with their trading partners. Test data is, of course, the most important and useful data set for this type of analytics, hence our focus on that aspect of data. But any other type of data can also be brought in and combined with those data sets to generate a more holistic picture. And finally, the biggest challenge is the many-to-many nature of the value chain, requiring a hub-based solution that provides the analytics with minimal IT overhead. But on the flip side, the good news is a lot of the technology is already there, and we hope to be piloting these capabilities with several customers soon. We're looking for companies who would like to participate as development partners in this project. So if you're interested, please reach out to us. And that's what I have to tell you today. So thank you. If there are any questions.
Thank you, Michael. Yes. What kind of latency do you expect with this hub architecture as you're going and requesting data sets from each of these partners?
That's a great question. Yeah, we're not expecting for most use cases that this would be anything like real time. In other words, you wouldn't expect to bring data in during package tests and immediately respond or immediately leverage it. However, we've already got a lot of experience in what we call data feed forward, which is ensuring that certain data is available downstream, for example, from wafer sort to final test to enable better decision making at final test. NVIDIA presented about that many years ago, demonstrating how we were using that for drift detection, for example. Now, if a supplier of data is prepared to share part of a data set or the specific aspects of a data set that could be leveraged at package test, it would be possible through the hub to make that data available at the assembly house ahead of time, so that when the package part is actually being tested, that data is available for to be included effectively in the output of that test program, or to be leveraged by the test program.
Okay. Is it possible for, say, a chiplet supplier to be able to get data from the field on how their chip is working back there? Is it kind of a two-way street where the data is going to all suppliers?
Absolutely, it is, yes. And again, even before we've launched this particular hub solution, we've already been doing that for some of our customers. They're getting in-field data back, which we're then using to better understand how certain aspects of the test process can be used to predict those in-field performance. And this is just an extension of that same capability.
All right. So somebody else says, with the hub concept of protecting data source details, when the analysis is done, wouldn't that identify where and which party caused the failure? And is there any concerns about kind of liability and identification?
No, that's also a really great question about how we actually reflect the results back to the parties. So potentially, of course, the data would show some kind of relationship. But it then becomes a question of the business arrangement between the parties about which data is actually shared back to each side in the event that a correlation is found. So, for example, it would be possible to define a methodology where only the supplier gets that particular data set, and then they can choose if and how they want to respond to that for their customer. But remember, the suppliers very often do have a desire to work with their customers to improve their quality, to improve their yields, and so on. And to differentiate themselves from other suppliers. And we believe that this is an inevitable movement in the market. So yes, these problems do exist, but we believe that over time, organizations will become more comfortable with that kind of communication with their customers.
Can you speak to, with this hub, are we essentially putting our trust in NI at this point to make sure the data is safe and secure? Is there any thoughts about how consumers and vendors are going to understand how the hub works to ensure that their data is safe?
Yes, of course. Well, as I said, this is actually part of a much broader concept, which is being driven out of Europe, where, of course, privacy, sovereignty, data ownership, and so on are the key concern. So, and as I also said, this is federated services, right? So very often that data is not actually going to reside on the hub at all. We intend to conform with the methodologies that Catena-X and GAIAX and other such consortium roll out over the next few years, so that we can provide a solution that would be acceptable to the industry. And we will, of course, be very transparent about the policies and the methodologies used to manage customer-sensitive data. And again, we do a lot of that already today, right? Because we do have access to data sets on behalf of our customers, For many of our customers, we are wired into their manufacturing operations, which are very often outsourced. We have access to their data sets when they're in the foundry or test house. We have access to that data as it's in transit. And therefore, of course, all of that is, we are intimately aware and have a good understanding of what we need to do to make our customers comfortable with that aspect.
Okay, so no plans to open source the hub for everyone to check out?
Not at the
moment. Can you speak a little bit, a lot of people hear about blockchain and it was in your presentation. How is this different from kind of a distributed blockchain approach versus the hub?
Yeah, so blockchain is a really interesting technology, and in my opinion, the hub will use blockchain. I think the blockchain will be a part of the solution to enable the tracing of every data transaction. So it will contain, for example, some kind of checksum or signature of digital signature, effectively, of every piece of data that was shared, but it won't contain the data itself. Blockchain doesn't scale well to very large data sets. And one of the problems with blockchain is that every participant in the blockchain has a very large replica of all of the data. And of course, a lot of that data is not actually relevant for them, even if it's encrypted. It's not data that you actually want to have available on everyone's machine. So blockchain definitely, yes, as the distributed ledger to oversee the transactions, but not as the engine through which the data itself is shared, in our opinion.
Okay. I have another question. So as we are talking about larger and larger amounts of data, how do you see being like essentially the cost of this infrastructure being distributed, right? Assuming somebody's got to have to host all this data through these federated services, and it might be a quite large transfer of data. Is there any thoughts on how that cost and compute would be managed?
So actually, that's the beauty of the solution, right? Because the data isn't residing anywhere where it doesn't already exist. Okay, if you have, let's take, for example, we take some of our large semiconductor customers, like some of the big fabless players. They've already got the databases with all of this data. All we need to do is provide a service gateway with which the hub can actually access those services directly. So yes, there is movement of data in order to perform the analytics, but that data doesn't have to be stored in an additional location beyond where it's stored already today. Now, the even better news, of course, is that for many of our customers, they are either already on the cloud today or moving to the cloud. So creating these links, it'll all be within the infrastructure of cloud providers. It becomes much easier, reduces costs, and makes it very easy to run this kind of analytics across multiple organizations.
So are you kind of implying that some of the analytics and compute would actually be pushed to the data versus actually pulling a lot of that data to a separate compute node? I mean, in the cloud, right, that kind of makes sense. We can spin up compute next to the data.
It's a good question, but the way I would frame it is slightly differently, because you can't just push the analytics to the data, because the whole point of the analytics here is to look at the combined data set. For example, if I'm correlating data set A with data set B, the compute resources that are doing that correlation will need access to both of those data sets, right? However, if you're doing that on the cloud, then there's no data egress because both players are on the same cloud infrastructure at a high level, for example, in the same region in AWS or Azure or whatever, then there can be significant savings. Now, the other part of it, Neil, of course, is you're not going to typically do this on your entire data set. There are going to be specific parameters or specific types of data that are relevant for this kind of analytics. So the users will be able to define that up front, and you're only going to be moving a small subset of the hundreds of terabytes that some of our customers collecting on an annual basis.
All right, excellent. I think I have one final question. Do you have any techniques or processes that can actually operate on, say, encrypted data? You talked about obfuscation. That does work at some level, but I'm sure you talk to a security expert, they'll say that's worthless. Is there any actual way to operate on say, an actual encrypted set of data?
Well, I'll challenge the security experts on the worthlessness of obfuscation. There are obfuscation of code is worthless. You can reverse obfuscated code pretty easily. Obfuscation of data is not worthless. And again, I won't be able to. I don't want to talk too much on the details of that because we have a lot of research work going on, but it is actually quite valuable. There are other techniques, and we're actually looking at some of them. There's a technique called homomorphic encryption, where data sets can be encrypted. They can then be analyzed together, and the results are encrypted effectively with that same key. And all of that is done without decrypting the data in transit or during the analytics. However, they require a lot of processing resources to perform. They're expensive, and they're also quite limited in the type of analytics that's possible to do. The structure we're planning to design for the hub is a plugin structure that would enable vendors to plug in their own analytics capabilities, their own analytics algorithms and so on. So we will be working with third-party vendors. We're already talking to third-party vendors about possible implementations of homomorphic encryption for some of this.
Excellent. Very interesting. One more question on the chat. How much customization is needed for the analysis by product or by chip? Is this days or weeks, or kind of how long can you enable a new product?
Yeah, well, again, this is still a concept that we're working on. I would expect it's probably days or weeks and not hours or minutes. And some of it might actually evolve over time, because I think as there's a growing learning of how a particular device is used, is actually used, you're going to be learning more and more and more about the kind of failure modes and so on that you need to be looking for. So I believe that some of this will evolve over time. And of course, as the use of the hub becomes more prevalent, we believe that time will shrink over time.
Okay, thank you very much.
I'd like to thank all the presenters and also thank all the sponsors who made this event possible, and their generosity covered the expenses, so everybody was able to attend without charge. Our diamond sponsor is Omcor, with differentiations in technology, quality, and service. Our emerald sponsors are Advantest, voted #1 in ATE by the VLSI survey in 2001, and Synopsys, silicon to software. And then our Ruby sponsor, Tech Search International. So once again, if you have an opportunity to thank the sponsors, please do so, to encourage them to help support future events and bring great information like we've had over the last 3 days here at Data and Test Road to Chiplets. And with that, I will wish everybody a good rest of your day. And thank you for joining us, and look forward to seeing you at a future MEPTech event. Thank you.